Hey guys, um, yeah, today we will learn about the action of reactive power in a power system, like how it works and what does it do, like deeply, you know what I mean. So first of all, we need to see here. I'm not sure you guys can see this word or not. So from here, power plant, like a generate part, right? It's generate electricity, and then there's a step up transformer, and you sometimes can see transmission line, right? And then stepped out transformer, like I would say substation, we stepped out, and then also one more time step down around the our house. There's step down transformer, here. So first of all, we already know that generator make it generate power, you know what I mean, like electricity, and it you know moves the power to the our house, right? But transformer is needed because of a power, loss on the way. It's kind of a long away, right, from our house, at least you know like 100 hours, like almost 1,000 kilometers, depends on where you live, right? So yeah, this is a general, broadly we could see the power system, you know what I mean here. So today we will focusing on a little bit about I will quick review about this first, about the generator. So synchro generator, later we will learn it, okay? Don't worry about it. So I constantly repeat about the reactive power and active power, right? Here you guys can see here rotor. Rotor is inside, right? It's a rotors also connected DC supply. We say this is excitation. So it's actually control the reactive power here, this part. And here you can see the black dot. It actually connected like a prime mover, like a stick, you know what I mean? To understand easily, stick. And then it needed from some power, like wind or steam or hydraulic or geothermal, whatever, you know what I mean, from the power source. It made it then pro prime movers to rotate it, you know what I mean. So this is related frequency, and the speed is a frequency, right? So it's actually related active power. So yeah, so far I said was this. So let's see first. Here, I wanted to say, you guys, the I. Okay, let's move on. I will draw. So as we know, I said there's a active, and here's reactive, right? And this is just, okay. This is I, and this is I cosine zeta here, this part, and this is I sine zeta, right? So if we add multiply v, so here's we since use a voltage source, right? So there's a standard reference point. So if we apply multiply here v, so vi sine zeta is q, and then vi cosine zeta is p, right? So actually current have a two side, you know what I mean? Active power and the reactive power. So today I wanna say is here. I will draw a simple, our power system. So generator, right? And then here, for example, factory motor, right? and it make it PQ, needed PQ. But on the line, there's a jet, I would say, R plus JX. And then here's I would say. So this is broadly we see a power system. Sorry about. So power system. So look at that. The generator, it need to make it P and Q, right? Because the motors needed P and Q, right? But about the efficiency, we need to say. So look at that. So we say here, we say generally power loss, we say, right? I to 2 multiply R is active power loss, and I to 2X is a reactive power loss. So which means loss means, on the way, it's because of, resistance, it just gone. We actually, what I mean is we actually didn't use it, just on the way we lost. For example, here's 100 volt, started, G generator, it make it 100 volt, but because of the voltage drop, we say loss. Because of too much long line, and then there's resistance, you know what I mean? So that's why 40 volt is loss, just gone. And here's 60 volt. But to, operating this motor, we needed, what's wrong? We needed 80 volt to operate this motor. So that's a problem, right? So as I said here, it's really, a burden to the current, to bring active part and the reactive part. You know what I mean? So because of, it's a too much magnitude is kind of large. In the pager, this length is, we say, magnitude. You know what I mean? The longer is means the large number, you know what, magnitude. So it's kind of burden. We don't want a loss, right? So we decided to, install some specific equipment. You guys generally heard like a capacitor bank. It makes, for example, from here, this part, we added capacitor bank here. So after then, what happened is this loader's, side of voltage is up because of C. We say, we say this is phase modifying increment. So it could be capacitor or, capacitor or, what was it? Coil, you know what I mean? Inductor, yeah. Inductor, sorry. Inductor or capacitor. This is, called modifying the power factor increment. So later we will learn it, okay? Don't worry about it. Just so my main point was because of too much loss, we decided to add on the line here, right? So, and then we will, I may mention about, I'm not sure, but G is, G could generate P and Q both, but P generate is, more better to generate P part only. You know what I mean? So let's see more. So what I wanna say is, you guys, when you have time, try to do, draw and then understand. You know what I mean? PQ, right? Yes. Impedance. Z R plus JX. Yeah, there's motor. Okay. So we decided to add here C, right? So we first need to know why, how, C. If we add C, how it, make it power factors improved. So for example, I show you guys. So first of all, I said in the daytime, we generally, for example, most of factories needed load, right? Motors needed work, right? So our general, so I said V0, we since use the voltage system, right? So this is a reference. So current is it gonna be here, generally lagging. You know what I mean? I, yeah. But look at that. Since this C is connected near the load, motor. So how it happens? But as we learned about C is leading, and the coil is coil inductor. Okay, I will say I inductor. Inductor is lagging. How it works like that? How the capacitor, gives to the motor like a lagging, current. We wondered, right? So let's see how it works. So first of all, here, look at that. The C is leading, right? Leading is more, in the page, more the faster, not faster. What I mean is in front of them, it exists, right? So it's C is here, right? But look at that. Broadly, motor is, provider, you know what I mean? Not supply, you know what I mean? G is supply and motor is use, right? And then C is also same meaning. We think C is also making Q part of this Q part of generator, we think. So when you get the current, you also need C, this lagging, you know what I mean? Sorry, leading. But if we, works like as a supplier to the motor, this is now supplier, right? Where at first time, when it spent the leading current is this capacitor was as a provider, like a motor, you know what I mean? As a provider. But now it changes to the give, it's the capacitor gives the reactive power to the motor. So now it's as a generator supplier, right? So that time it changed this part. The pages, because now when I use it, I spend the leading part. But when I give you that, I provide you lagging current. Because giving and getting and giving is different, right? So when I getting lead, right? When I provide, so this amount of current, I also, like for example, say, right? So this I also, provide, supply, gives to the motor. So, which means, so this part, C is provided. So which means it needs this part. So for example, so if we do a phasor here, which color is better? This color. So the current is gotta be this. You know what I mean? Because it provided this part, it since it use it, but we just said, reverse way, because now it's provider, you know what I mean? Not consumer, just provide as a generator. So generator only needed this part, you know what I mean? It need to make it Q here. Because of this capacitor bank provide C here near the motor, you know, it near the load, you know what I mean? So because since we installed this capacitor bank, the power factors, you know, improved. Here, look at that. Power factor is, you know, the phase differences between V and I, and why we use it because of money, right? If we board to improve power factor, it save money, right? That's it. Yeah, and yeah, we now move to the slide, and I will check it if I miss something or not. You know what I mean? Here. So I'm saying is, you know, page modify equipment, it could be, you know, inductor or it could be capacitor. Later we will learn about when we need to use like inductors as a, you know, page modify. You know what I mean? At nighttime, it's a penalty effect to happen later. Later we will learn. Okay, so that's why we need because of this VR part is you know, so much improve the VR part, the load part voltage is, you know, too much, you know, increased. So we needed reduce this voltage. That's why we use inductor. Later we will learn, okay? Don't worry. And as you can see here, VR is here. So reference point here, right? But C is working. I mean, when it's as a consumer, like it needed leading current, right? But as a provider, the page is, you know, reverse here, this part. So that's why if we add this line, and then the I, total I, this I is load current. So it changed, it's improving like this. Yeah, that's it today's lecture, guys. Thanks.